Hello, today we're going to be looking at how to write a function. We're going to write an equation from a transformation. So really this is going to be the opposite of what we've been doing for the last couple of weeks. So instead of taking a function and saying, look, this is what happened arithmetically in the function. We added, we multiplied, we divided, and this is how it's going to change the graph. We're going to do the opposite. We're going to look at a graph and we're going to say, okay, how is this graph different from the parent? What needs to happen to get it there, and then how does that affect my equation? So I'm going to look at 3 graphs right now, and then when we're done, I'd like you to go watch the second video, which will do the same thing but with tables instead. Alright, so here we go. Let's look at the first one right here. The first important thing that we need to do is identify the parent function. What is this parent function? Well, the parent function is the blue one, obviously, right there, and that is a quadratic. So the parent is y equals x squared. Okay, so now let's look at the red graph. This is the one that's obviously been transformed in some way. Let's see if we can figure out what is happening to this graph. What's happening to each of those points? Now, a good place to look to start with is usually the vertex. The vertex was at 0, 0. What's happened to it? It looks like it's been moved 1, 2, 3 spaces to the left. So that's going to be my initial guess. 3 spaces to the left. All right? Now, let's check some other points and make sure that that's really what's happening. Because if something else happens, if there's also a stretch or squish or flip or something like that, then that would show up elsewhere. So let's just check a couple other points. So if we start here, let's take this one, 1, 2, 3. Oh, that one moved 3 to the left too. And this point right here, 1, 2, 3 to the left. So it looks like pretty consistently everything is moving 3 spaces to the left. Now, let's see if we can now put that with the function. Now, when we move 3 spaces to the left, that is a horizontal change. Okay? Now, if we want to be working horizontally, then what does that mean? Do we need to apply it to x or outside of the x? Well, hopefully you remember that rule number 1 with our transformation was if you do it to x, it will cause a horizontal change. So therefore, if we want a horizontal change, we need to do something directly to x. Not to the x squared, but to the x. Now, what do we need to do? Well, we need it to shift 3 spaces to the left. And you may remember that with x, it is the opposite of what you would expect. So you might say, well, to move to the left, I need to subtract 3. But x has to be the opposite, which means I need to add 3. So that's what needs to happen. I need to add 3 directly to the x. Now, don't get confused. Don't do this, because that 3 was not added directly to the x, was it? So I need to rewrite this in such a way that it's y equals. Now I want to add directly to the x before I square it. So I need to have an x plus 3, and then it needs to be squared. This equation right here represents that red function right there. Pretty awesome, huh? Let's do another one. That was pretty cool. So let's do it again. Let's look at this one right here. Now this one is what type of parent function? Yes, I heard a resounding exponential all the way across the city. So yes, that is an exponential graph. So the parent, as far as we're concerned, is y equals 2 to the x. All right, now what's happened between the blue graph and the red graph? Has it just moved over one way or the other? No, that doesn't really work, because I can't, if I move this one looks like it's been moved over maybe 3 spaces, but that one's been moved over 4, and this one hasn't been moved at all. So it doesn't look like it's a shift. It's not really a stretch either. If it was stretched, it'd just be a little bit taller or squished a little bit wider. So what's happening here? Well, hopefully you can see that this point right here on my original graph has been reflected over there. This point right here has been reflected to the other side, right there. Now, one way that you might be able to see this is if you actually write down some points, and you'll be able to see that the points are being reflected. But we can recognize from this that that's what's happening. All those points, right? This point right here, 1, 2, 3 spaces needs to be reflected 3 spaces on the other side. Oh, there it is. See, it's being reflected. It's very easy to pick off a single transformation. So we need to flip it. What type of flip is this? Well, the points are moving side to side, which is a horizontal flip. So that's what's happening. So on your homework, I'm actually going to ask you to list what's happening. So this is a horizontal flip. Now think back to what we've been doing. What causes a horizontal flip? Well, you may remember that a flip is caused when there's a negative. Now, where is that negative going to be? Because I can think of a couple of places where I could put it. I could put it here in the front of the 2, or I could put it right in front of the x. Now, if we want it to be horizontal, where does the negative need to be? Needs to be applied to the x. And so that means it's going to be y equals 2 to the negative x power. That would cause a horizontal flip. There we go. Done. That was so much fun. Let's do one more. Yeah, we're not done. Let's do one more. Here we go. Oh my goodness, absolute value. Ouch, that hurt. Okay, well, here we go. Absolute value. Let's look at this absolute value graph and see if we can write an equation for it. All right, so the parent function, which one's the parent function? Blue or red? Well, it's blue, Mr. Bywater. Well, yeah, it's blue. Why? Because it was blue in the other graph. No, that's not why it's the parent function. If you look at it, it goes to 1, 1, 2, 2, 3, 3. That's why it's a parent function, because it's actually doing what the parent function does. So that's the parent function, which is y equals the absolute value of x. So now we need to look at it and say, okay, what is happening here? Does it look like the blue graph is just moving up and down? Hopefully you said no. A good indication of that is note that the vertex is in the same place both times. Right? Up here, a good indication that it wasn't moving up or down was the fact that the asymptote was in the same place both times. If the asymptote hasn't moved, it's very likely that it hasn't moved up or down. If the vertex hasn't moved, then it probably hasn't moved up, down, or side to side. So this can't be a shift. It's not flipping either. So the other option is that it could be stretched or squished. Now the nice thing about this is you could look at it in any number of ways. There's 2 different ways you can look at it. And I'm actually going to show you both of them because I'm at 7 minutes now. I got 3 minutes left to spend on this video. So let's go ahead and look at it. Okay, let's pick off a couple of points. Let's choose this one. Let's look first and say the obvious one to most people is that this is getting squished vertically. Okay, now you can see that right here, no! Right here, the y value is at 4. It needs to end up going down to the 2, right? So how do I squish from 4 to 2? What do I need to multiply by? Or what do I need to divide by to get from the 4 to the 2? Well, hopefully you recognize that that is dividing by 2 or multiplying by 1/2. Okay, divide by 2, please remember, is the same thing as multiplying by the reciprocal, which is multiplied by 1/2. And since we usually deal with the multiplication, that's actually what you want. You want to think of it in terms of 1/2. Let's look at another point and see if it works. Let's take this one right here. That one is up at 6, and what happens vertically? It's going down to 3. Is that half? Why, yes, it is. And I think any point that you check will have that same occurrence. The y values are being multiplied by 1/2. So how do I get that to occur in my equation? Well, remember, if it happens inside the function, it affects x, and it's opposite. If it happens outside of the function, it's exactly as it's stated, and it affects y. So I want to affect y. So does it need to be inside the function or outside the function? Hopefully you said outside. So I know it needs to go outside. And what do I want to happen? I want it to multiply by 1/2. So I'm just going to take the outside and multiply by 1/2. And there you go. It's done. Now, that would be perfectly fine. But I want to cover one other base. I want to say, okay, well, what if I wanted to look at this horizontally? Can I do that? Can I do that? Can I look at it horizontally? Well, let's see. Let's take a point. Here's 2, 2. If I move it horizontally, what happens to the x value? Now you may say, well, it added 2, but we're not talking about a shift. So it can't be an add. It has to be a multiplication. How do I get from 2 to 4? Well, x has to be multiplied by 2. All right, well, let's look at another one. How about this one right here? X is at 3. What does it become? It needs to be multiplied by 2. So we need to multiply x by 2. Now, in order to multiply the x's by 2, 2 things need to happen. Number 1, in order for it to be horizontal, it needs to happen inside the function. So this time, it has to be happening inside the absolute value bar. Now, the second thing is that it has to be the opposite, right? So it can't be multiplied by 2. What's the opposite of multiplying by 2? Well, it's dividing by 2. And dividing by 2 is the same thing as multiplying by 1/2 because I'm just flipping and multiplying by the reciprocal. So in this case, I just need to go 1/2 times x. And 1/2 times x, you'll remember, will cause a horizontal stretch of 2 because that's the opposite of 1/2, and that's what's happening is a horizontal stretch. Now both of those worked out. They both ended up being 1/2. That's not necessarily the case in any situation. So you do have to still think through it. You have to figure out what's being multiplied or what's being divided. And there you go. That's all there is to it. So hopefully that will help you. Most of your homework tonight, I believe, is all one-steppers. I may have thrown in a two-stepper with 2 shifts, but for the most part, it's just one step. Figure out what's happening. Is it shifting? Is it flipping? Or is it being stretched or squished? All right, so there you go. Good luck on your homework. Well, okay, no homework. You'll do it in class tomorrow. Ciao.